Okay, so let's start the chapter. I'm sharing the screen. Okay, is it visible to you?
Oh yeah.
Okay, so the chapter which we are going to discuss is chemical bonding. ICSE class 10th chemistry chapter, that is chemical bonding. Chemical bonding. This is the chapter which we are going to discuss. Okay, so
Yeah.
as the name suggests, all right, chemical bonding, it's a chapter in which we will be studying about the bonds between the two atoms or more than two atoms, molecules, etc. Okay, now what is a chemical bond? Let's discuss about the definition of a chemical bond. If someone asks you the definition of a chemical bond, how you are going to define the chemical bond basically? So chemical bond, it is the force which holds two or more atoms together in a molecule. So what is a molecule? Molecule is made up of two or more than two atoms, right? Group of atoms form a
Yeah.
molecule. Okay,
Yeah.
so inside the molecule the atoms, they are bounded together, but they will be bounded together by a certain force. Okay, and the force which is acting between the molecules, two or more atoms, okay, and the force which holds these two or more atoms, that is called as the chemical bonding. Clear?
Yeah.
So I'm writing here, wait a minute, let me write. Now what is a chemical bond? Chemical bond is the force which holds two or more atoms together in a stable molecule, that is called as a chemical bond. Clear? Now in the
Yeah.
previous class we discussed about atoms, right? What is an atom?
Mm-hmm.
Hmm?
Yeah.
What is an
Yeah.
atom? We discussed that atom is the smallest unit of a matter, right?
Yeah.
That takes part in a
Yeah.
chemical reaction, and it has subatomic particles. We discussed various theories, right? Dalton's atomic theory. After that, there were certain more atomic theories based upon the structure of atom came, like Rutherford model of an atom. Hmm? Then
Mm-hmm.
the first theory we discussed was a Thomson's model of an atom, also called as the watermelon model of an atom. So we discussed these. Okay, and the reason Dalton's atomic theory was failed because it used to say that atom cannot be divided. However, later the subatomic particles were found out, which were electrons, protons, and neutrons, which were called as the fundamental particles or the subatomic particles. Right?
Yeah.
Okay. So now we will be discussing about the elements. What are elements? Elements, they are involved in a chemical combination and are made up of only one kind of atoms. Okay, so now we will be discussing about the types of elements. Our next heading, types of elements. This is going to be our next heading. So how many kinds of elements we have? Obviously, number one are the metals, another one are the non-metals, and then we have the metalloids. Okay, so first
Yeah.
let's discuss about the metallic elements. Metallic elements. What are metallic elements? You know very well what are metallic elements. In the last shell, which is also called as the valence shell, they have how many electrons? 1, 2, or 3. Okay, so metallic elements, what they have? They have 1, 2, or 3 electrons in the last shell, also called as the valence shell. Clear?
Yeah.
This is called as the metallic elements. Now after that we have another group of elements which are called as the non-metallic elements. We will be understanding this with the help of an example. Non-metallic elements. Now what are non-metallic elements? Non-metallic elements, also called as the non-metals, they are those which have how many electrons in the valence shell? Tell me.
5, 6, 7.
5, 6 or 7, 4, 5, 6, 7. Even 4 is also there. Okay. 4, 5, 6 and 7. 4, 5, 6 or 7 electrons. Okay.
Yeah.
In the valence shell. I am writing here in last shell, also called as the valence shell. Clear? So
Yeah.
these are the types of elements. Now let's discuss about the metals and non-metals. For example, when we are talking about the metallic elements, let's talk about the example of the metallic elements. When I am talking particularly about the metallic elements, this means that in metallic elements, the last shell will have how many electrons? 1, 2 or 3. For example, sodium, Na. So for sodium, what is the atomic number? Atomic number is 11. Right? Atomic number is 11. This means atomic number is 11. So how many electrons will be there in the last shell? Let's write the electronic configuration: K shell, L shell and M shell. So 2 and 8, 10 and 1. So last shell has how many electrons? 1 electron. Right?
Yeah.
So this means that it is a metal. It is a metallic element. Which means, what do I mean by the metallic element? This means that it is going to lose the electron to form the stable configuration. Okay? To achieve the stable noble gas configuration, and it is going to form the positive ion, also called as the cation. Which means that if it will lose 1 electron, it will become Na plus. Right? When it will lose, and this is called as the cation. Positive ion, also called as the cation. Clear?
Clear.
Positive ion, also called as the cation. Okay? I hope it is clear to you.
Yeah.
So this is the positively charged ion, also called as the cation. The same goes with the calcium, okay, magnesium, aluminium, like this. Okay, so this is for sodium. Now let's move ahead and let's discuss about the non-metallic elements. Okay, so in the non-metallic elements, what we discussed, that the last shell will have how many electrons? Tell me.
4, 5, 6 or 7.
Very good. Non-metallic elements. Let's take one of the example. For example, very best example, chlorine. Okay, chlorine.
Yeah.
So atomic number for chlorine is what? Tell me.
17, I think.
Very good. Atomic number is 17. Okay, now let's write the electronic configuration. Electronic configuration is going to be what? K, L and M shell will be there. So 2 and 8, 10. 10 and 7, 17. So how many electrons are there in the last shell, the valence shell? Tell me. 7.
7.
And when there are 4, 5, 6, 7 electrons in the valence shell, this means that it is a non-metal, and it is going to lose, it is going to attract 1 electron, it is going to gain 1 electron to form the negatively charged anion. Okay, Cl minus. So what it is going to do? It is going to attract electron, it is going to gain electron to form negatively charged ion. Okay,
Yeah.
negatively charged ion, also known as anion. I hope it is clear now. That is non-metallic element, chlorine. Best example is chlorine. Okay, we will again take these examples. Okay, Our work is not over here. Now let's talk about the chemical combination. Okay, we have discussed all of this. Now let's discuss about the chemical combination. What's a chemical, which means how these atoms will combine together, okay, to form the compound, how these molecules will form, elements will combine together to form the compound. Okay, what is a compound? Compound is basically made up of elements, right? Group of elements, they form the compound, obviously. So how will these molecules will combine together, elements will combine together to form the compound? Chemical combination. So let's take one example. Now, how these molecules form? Molecules are formed through two means. How? Transfer of valence electrons.
Yeah.
Okay. Transfer of valence electron. Electrons from where? From a metallic to non-metallic element. Okay, where? From a metallic to non-metallic element. Okay, how is it possible? Let's take the example. Example is NaCl. Okay, so NaCl, I am going to draw NaCl here. So this is Na and this is Cl. Okay, how many electrons are there in the valence shell of Na? 1. And Cl, how many electrons are there in Cl? 7.
7.
And the last shell?
Yeah.
Now, Na will lose to achieve the stable noble gas configuration, while Cl will gain electron to achieve the stable nearest noble gas configuration. So this electron will be shared here. Yes or no?
Yes.
And they will form a bond. And this is the compound NaCl which is formed. Clear?
Yeah.
NaCl. This is how NaCl is formed. This will become Na plus and this will become Cl minus. Okay, and this electrovalent bond is formed. Clear about this?
Yeah.
Okay, this is NaCl. Now after that there is another method where the atoms combine to form a molecule, and that is called as the sharing method. Sharing of valence electrons. Okay, so let's discuss about the sharing of valence electrons. Number second method, sharing of valence electrons. Sharing of valence electrons. Okay, between two atoms. Between two atoms. How is it possible? Let's look out. Let's take the example. Okay. For example, CH4, methane. Methane is the best example. Okay, I'm giving you one example, CH4. So carbon, this is carbon, right? This is carbon. Okay, carbon. Now, how many electrons it has? Obviously, it has 4 in the last shell. Okay.
Yeah.
4. Basically, those elements which have the 4 electrons in the valence shell, they do the sharing because they can neither lose nor gain the electrons. Okay, that's the reason. Now let's take this will be 1H.
Yeah.
Okay, let me draw by my own. So this will be 1H. Okay, and hydrogen has one electron in the last shell. Okay,
Yeah.
similar is with this. Okay, similar is with this. And similar is with this. So what is this? CH4, also called as methane. Methane. Clear?
Clear.
Now, so this is how electrons are shared between the two atoms. Okay?
Yeah.
Alright?
Mm-hmm.
Okay, really very good. Now in your book, if you come to the second page, to page number 22 of your book, you will find various structures here. Okay, the first three periods are given: hydrogen, helium, lithium, beryllium, boron, carbon, hydrogen, oxygen. The first three periods are given to you, and their electronic structures are made. Okay, so it is really very easy to make the electronic structure. Let's draw the electronic structure of aluminium. Okay, electronic structure. Very easy to make the electronic structures. How? First, what I am going to do, let's make the electronic structure of aluminium. Aluminium. Now aluminium is denoted by the symbol Al. What's the atomic number? Atomic number is 13. Okay, atomic number is 13. So if atomic number is 13, what does it mean? What does it mean? Which means that atomic number is 13. So number of protons will be how much? It will also be 13, and number of electrons will also be 13, right?
Yeah.
So because in atomic number is denoted by the symbol Z. Z equals to number of electrons equals to number of protons. Okay, because element overall is what? Atomically neutral, is electronically neutral, right? Electrically it is neutral. Now, so Z will be what? 13, which means number of electrons and number of protons will be equal to how much? It will be equal to 13. Clear? And what is the mass of aluminium? Mass is actually 27. How much? 27.
27.
Now what are the number of neutrons? Number of neutrons, mass number is basically made up of protons, number of protons plus number of neutrons. I told you that the whole mass of the atom is because of the protons and the neutrons.
Yeah.
Right?
Yeah.
Number of neutrons. So what will be the number of neutrons? Mass number is given 27. Number of protons are given how much? 13. So what will be the number of neutrons? N. N will be equal to 14. Right?
Yes.
So we can now easily draw the electronic structure. How? Very easy. So protons we have. So let's take here the nucleus. So inside this nucleus, how many protons we have? 13. Right? So I am writing 13 protons and 14 neutrons. 13 protons, 14 neutrons. Okay? For aluminium. Okay, but do one thing, just make a little bigger here. Okay, okay, like this. So this is aluminium. Okay, how many protons are here? 13 protons and 14 neutrons. Clear?
Yeah.
Then after this, what we are going to do? We are going to draw the extra nuclear part here. So K shell, L shell and M shell. If you write the electronic configuration of aluminium, what's going to be the electronic configuration of aluminium? K, L and M. So 2 and 8, 10, 10 and 3 is 13. Last shell has 3. Okay, so remember this. So we will draw first shell. This is second shell. And this is third shell. Okay, since I am drawing with a pen, when you will digital pen, when you will be drawing with the paper on the paper, it is going to be come really very good. Okay, so how many electrons are going to be here? So in the first shell 2, so let's make 2 here. Okay, for aluminium. Clear what I'm doing here?
Yeah.
2 here. Then we have how many electrons here? 8. Yes, L shell.
Yeah.
So make 2 here. 2, 4, 6 and 8. Clear what I'm doing?
Yeah.
Okay, and let's make the 3. Okay, you can draw 3 on any side. It doesn't matter where you are drawing. Okay, you can draw anywhere. So this is the electronic structure for aluminium. Clear?
Yeah.
Okay.
But can you go to the last page for 1 second?
Last page.
Yeah, just
Yeah. So just
yeah,
copy it
that's
down.
yeah. Yeah.
Okay, now let's discuss about the noble gases. So this is for aluminium. In the homework you will draw for sodium and magnesium. Okay.
Okay.
Yeah, sodium and magnesium, Na and magnesium. So you have to draw the electronic structures.
Yeah.
Okay, this is the homework for you. Now I hope it is clear to you. So let's discuss about the noble gases. Okay,
Yeah.
let's talk about the noble gases. So we know very well what are noble gases. Okay, so they have the complete duplet or complete octet. Okay, they have stable electronic configuration. Their outer valence shell is completed. Okay, completely filled. Okay, so I'm writing one point here. What they have? They have stable electronic configuration. Clear? That is their outermost shell is completely filled. Clear?
Yeah.
Okay, now you can see the example. For example, if we look about helium. Okay, what is the atomic number for helium? 2, which means the last shell will have 2 electrons, right?
Yeah.
For example, helium has how much? 2 electrons in last shell,
Yeah.
which means its duplet is full. Okay, now for example, neon, argon, krypton, all these have complete 8 electrons in their last shell.
Yeah.
Okay, similar goes with this. So all the noble gases, they are unreactive unless certain special conditions are not provided to them. They will not react. They have, because they have the stable electronic configuration. Okay, they cannot form cation, anion, just like we were seeing in the metallic and non-metallic elements. Okay, metallic elements were forming the positive ion by losing one electron, and non-metallic ions were forming the negative ion by gaining one electron. Clear? Okay. So basically, this means that for an atom to achieve the stable electronic configuration, what rule must be there? Either it should have complete duplet, which means duplet rule, or it should have complete octet, which is called as the octet rule. 8 electrons in the last shell. Clear?
Yeah.
Okay, very good. So we have discussed about the electron transfer, we discussed about electron sharing.
Yeah.
Okay, so electrovalent bond, also called as the ionic bond. Okay, now let's talk about electrovalency. Okay, let's talk about electrovalency. Everything else is same. Okay, electrovalency. Now, what is electrovalency? Just write the definition first, then we will understand this. Okay, now I am writing here the number of electrons donated or accepted by the valence shell, okay, of an atom, of an element, so as to achieve a stable electronic configuration. Is called electrovalency. Clear? This is called as the electrovalency. Okay. For example, if someone asks you what is the valency for magnesium, okay, so now magnesium, what's the magnesium? The symbol is Mg. Okay, 1224. Okay, now if someone asks you what is the valency for magnesium, how you are going to define it? Okay, so the atomic number of magnesium is basically 12. Atomic number denoted by Z, it is equal to 12. Okay, mass number is how much? Denoted by A, it is going to be equal to 24. Okay, 24 units.
Yeah.
Mass number is 24 units. Now atomic number we have, mass number we have, which means if I write the electronic configuration here, so what's going to be the electronic configuration? K shell, L shell and M shell. So atomic number is 12. 2 and 8 10, 10 and 2 is 12. Okay, how many electrons are there? 2 electrons. Okay,
Yeah.
so now it will lose how many electrons to form the to achieve the electronic configuration, stable electronic configuration? How many electrons? Tell me.
Can it be lost?
Yeah, 2 electrons it is going to lose so that it may achieve the stable electronic configuration, right? Like this.
Yeah.
So it will become Mg plus 2. Like this. Yes or no? Mg2 plus, which means its valency is what? plus 2. Clear?
Yeah.
Okay, valency is nothing but the combining capacity of the element. Okay, so how many electrons the element may lose, or how many electrons the element may accept, okay, to basically form the bond. Okay, that is the valency. To achieve the stable electronic configuration, okay, the number of electrons donated or accepted by the valence shell of an atom, that is called as its valency, electrovalency. Clear?
Yeah.
So right now in this case, what is the valency? It is plus 2. Now we can also find for aluminium, it will be plus 3. Now let's find for the chlorine. If I talk about chlorine, for chlorine also called as the Cl, the valency is going to be how much? Let's find out. Chlorine, it will be written as Cl, right?
Yeah.
So Cl 17 35.5, right?
Yeah.
So this means atomic number is how much? Z, denoted by Z. It is how much? 17. Mass number denoted by A. It is how much? 35.5. Let's write the electronic configuration. Electronic configuration is going to be K shell, L shell and M shell. So how much? 2 and 8, 10, 10 and 7, 17. So it is going to, what it is going to do? Gain or lose to achieve the noble gas configuration? Tell me.
Gain.
Gain. And how many electrons it is going to gain?
1.
1 electron. So valency in this case is going to be minus 1.
Minus.
Clear? That's the reason why Cl minus. Okay?
Yeah.
So now you are going to tell me the valency for oxygen. Okay? So what's going to be the valency for oxygen? Tell me.
So the atomic number is 8, so then it's gonna be 2 minus.
How much?
2 minus.
Minus 2, right?
Yeah.
Oxygen, very good. So oxygen, it is represented by the symbol O. Okay? And atomic number 8 is oxygen, 16 is the mass number. Okay, now let's directly write the electronic configuration here. Electronic configuration is going to be what? K shell, L shell. So 2 and 6. Okay, so it's going to achieve gain 2 electrons. Okay, 2 electrons to achieve the nearest noble gas configuration. So it's going to get how much? 2 electrons. So it will be minus 2. Electrovalency or simply valency is going to be minus 2. Clear about this? How to find the valency?
Yeah.
Okay, really very good. Okay. Now let's talk about the structure of electrovalent bond, of electrovalent compound. Let's talk about some of the structures of electrovalent compound. The structures of electrovalent compounds. Okay, so very first structure which we are going to discuss is sodium chloride. Okay, very first structure which we will be discussing is sodium chloride. Okay, sodium chloride also called as NaCl. Okay, we are going to discuss. Now how it is formed? It's an ionic bond, right? Electrovalent bond. Okay, So let's first discuss about its formation. So what's going to be the formation for this? Formation. I'm writing here. Formation.
Yeah.
Formed as a result of transfer of electrons. Formed as a result of transfer of one valence electron, right? We just saw in the
Yeah.
previous example when we were discussing this chapter in the beginning. Formed as a result of transfer of one electron, or you can say one valence electron. One valence electron. Clear? Okay. Now, how it is formed? I told you, basically because sodium loses one electron, chlorine will gain its electron and they will form the ionic bond. Okay. Understood? Now, let's discuss about the equation, ionic equation. I am going to write the ionic equation for you. So this is going to be the ionic equation for sodium chloride. Ionic equation. How I am going to write the ionic equation? Just have a look at this. Ionic equation is going to be like this. See, there is sodium. So what will sodium do? It will lose one electron to achieve the nearest noble gas configuration or stable electronic configuration. So Na will lose one electron and it will become what? Na plus. Yes or no?
Yes.
And remember, when an element or when an atom loses one electron, it is oxidation. Losing of electrons is oxidation. Clear?
Yeah.
Okay, so it has formed the Na plus, which is cation. Okay, so earlier Na was 281. This was the electronic configuration. When it lost one electron, it became 2 and 8. Okay, and this 2 8 is similar to neon. Nearest noble gas configuration means the configuration of neon, electronic configuration of neon. It is talking about. Clear about this? Because atomic number 10 is what? Neon, right? Na minus 1 electron. Now let's talk about the chlorine. What will chlorine do? Chlorine will gain electron, right?
Yeah.
Cl plus 1 electron. It will gain and it will become what? Cl minus. And when the atom gains an electron, it reduces. Okay, it is called as the reduction. Clear?
Yeah.
It is called as the reduction. So earlier the electronic configuration was 2 8 and this was 7, and this time it will become 288. The nearest noble gas configuration of argon. Okay, and now when you will combine all of this, so this was minus 1e and this is plus 1e, and when you will add this, it will become what? NaCl. Okay, Na plus Cl, it will become Na plus Cl minus, which is called as the NaCl. Clear?
Yeah.
Now let's talk about the electron dot structure. So this was the ionic equation. Now let's talk about electron dot structure. How to make the electron dot structure of this. Very easy. Electron dot structure. Electron dot structure. So this is how we will draw the electron dot structure, just like I did in the beginning. Okay, so this is sodium, Na. Okay, so Na, how many electrons it has? 1 electron in the last shell, and then we have how much? We have Cl. How many electrons it has? Let's put a plus sign here as well. How many electrons it has? Tell me, in the last shell? 7.
7.
3, 4, 5, 6 and 7. Now what will happen? It will move here. This electron is going to move here. Okay. Just do like this, simple. Okay. And then it will become what? It will become Na plus. Okay. It has used one electron and it will become Cl minus. 1, 2, 3, 4, 5, 6, 7, 8. Clear? There will be one minus here. Okay. And this will be NaCl. Clear how to draw the electronic dot structure? Electron dot structure?
Yeah.
Okay. Now, let's talk about the orbit structure. How to draw the orbit structure? Orbit structure is also very easy. Okay. Orbit structure. So how we are going to draw the orbit structure? Number 4. Very easy. Orbit structure. Okay. So I am going to do the same thing. Okay. So this is for Na. My screen is really very small. So let me draw like this. This is Na. This is the atom for Na. Nucleus. Okay. This is K shell. This is L shell. And this is M shell. Okay. Plus Cl. So Cl will be like this. This is K shell for Cl. L shell. And this is M shell. Okay. Now let's make the number of electrons. So K shell has 2 electrons. Then we have 8. So 1, 2, 3, 4, 5, 6, 7, 8. Clear? And the last shell has how many electrons? So 1 electron. Okay? In the Na. Now, the same goes with this. 2 electrons here. 1, 2, 8 electrons here in the L shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay? And how many here? 7. So 1, 2, 3, 4, 5, 6, 7 and 1 electron will come from here. Okay? Alright? And this will become what? This will become like this. I am drawing here. This will become Na plus. Again do the same thing. Na, K shell, L shell and M shell. Okay, K shell, L shell, M shell, and this will become plus because it has lost 1 electron. Okay, and it will be Cl and it will be like this. I am going to draw it at a little distance. Cl here. again this will be minus, because it has gained one electron, and this will be again the same thing, just remove one electron from here and the electronic structure will be same. One electron, two electrons, here there will be 8, 1, 2, 3, 4, 5, 6, 7 and 8. Clear? There will be no electron here as it is removed, and it will be plus. Okay. Now it will gain one electron and an extra electron will come here. The same thing. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Clear?
Yeah.
1, 2, 3, 4, 5, 6, 7, 8. Okay. No need to draw the fourth one because chlorine is actually 288 or 287. When one electron is added, it will become 288 minus. Chlorine will be like this. Clear? Like this. Understood? So you don't need to draw this, the last one. There it is empty actually. The last shell is the third shell. So you can actually rub this. Clear about this? How to draw orbital structure? Very easy. Okay.
Yeah.
So this is how we will draw. Now your next homework will be to draw for the calcium oxide, CaO. Okay. You have to draw the for calcium oxide structure of calcium oxide. You will draw this. That is CaO. Clear? That is also given in your book, but first try by yourself, and if you face any issue, then refer the book. Okay? Clear? For calcium oxide.
Yeah.
Same will be there. You have to write the ionic equation first. Okay? Then you have to write the electron dot structure, and then you have to make the orbit structure. Clear about this? So this is homework for you. Okay? So there are different structures which are given. Magnesium chloride is given. Okay? For magnesium chloride is given. So you can also try for the magnesium chloride. MgCl2. Magnesium chloride. Very easy. This is also really very easy. Okay? Magnesium chloride, MgCl2. This is a little different because Cl2 is here, so there will be two chlorine atoms. Okay? So its electron dot structure will be like this. I am going to draw electron dot structure for you. Mg will have how many electrons in the last shell? Obviously it will have 2. Okay? So one electron will be transferred to each chlorine. Okay? So chlorine has how many? 7. So this chlorine has 7. So one of the electrons will be transferred here, and one electron will be transferred here, and it will become what? MgCl2.
MgCl2.
Okay. Now how I know that this is going to be MgCl2? How I came to know about this? There is a formula which is called as the crisscross method. Okay. So here you will write Mg. If someone asks you to write the formula for magnesium chloride, so magnesium and chlorine, and just write the valency. What will be the valency for magnesium? It will be, tell me what it will be, +2?
So, yeah.
And this will be -1. Now just crisscross. So MgCl2. Clear?
Yeah.
This is how we will be finding it. Similarly for NaCl, the same rule, crisscross will be applied. NaCl. Na, the valency for Na is what? Tell me.
1.
Plus 1, and this will be minus
Yeah.
1. Just crisscross. It will be NaCl. Similar is with calcium oxide. Let's talk about the calcium oxide thing. So calcium oxide, CaO. Now what do I mean by calcium oxide? So CaO. How I am going to draw this? How did I know that it is going to be CaO, not Ca2O or not CaO2? How? If someone asks you calcium oxide, write the formula for calcium oxide. Very easy. So calcium, symbol for calcium is Ca. Oxide is oxygen. CaO. So for calcium is how much? Tell me. For C.
2 plus.
Yeah. Plus 2. Very good. And for oxygen?
Minus 2.
So it will be CaO. Crisscross it.
Yeah.
Okay. Simple. Understood?
Yeah.
So we will be following the crisscross rule here. Okay. So this is the homework for you. You have to do all this. So what we have discussed today so far?
The types of elements, the chemical combination, electronic structures, and noble gases, electrovalency, structures of electrovalent compounds.
Yes. Very good. So this is it for today. We have discussed a lot of things. Okay. In the next class we will be discussing about the covalent bonding. Today we discussed about the electrovalent bonding. Okay. In the next class we will be particularly discussing about the covalent bonding. Okay. How does this covalent bond forms? Okay. We will be discussing about the covalent bond formation between oxygen atoms, nitrogen atoms, and all of that. Okay. We will be discussing this in the next class. All right.
Yes.
Okay. Yeah. Any question or any doubt which you have? In the next class, this chapter will be over, inshallah. Okay.
Okay.
All right then.
Yes.
Any doubt?
Thank you. No.
No doubt. All right. That's really great then. So let's meet in the next class. Thank you. Have a nice day.
Thank you.